Hello and welcome to this online Empower session about swarming. Today we'll talk about swarming, what it is, why do we need it, and how does it work. So, getting started with swarming. What's on the agenda for today? First of all, we'll talk about what is swarming, why does it exist, what problem does it solve. Then we'll talk about swarming an element manually. Next, we'll talk about the automation capabilities. This is where the real power of swarming lies, and some use cases using this automation. Finally, we'll wrap up with a look at what's to come for future swarming development. So first of all, what is swarming? To understand what swarming is, we need to take a step back and look at what a DataMiner system is, how does it work, and what problem does it have. So historically, a DataMiner server was pretty simple. It was just a DataMiner server software running on a Windows machine, including its own database and some configuration files on disk. Typically, this runs some elements, some services, whatever, and this functionality was doing some things. For example, an element was talking to a device, monitoring something, whatever. Now, typically what happened was people kept on adding stuff to the DataMiner agent until eventually it overloads with a high load. What you could do then was add more nodes to your system and have them work together. So typically you connect with a client, the DataMiner cube, and you see your system. So once you add more nodes, you have more resources available, and you can keep on adding new functionality to your cluster. Keep creating more elements. However, there is a typical problem here, and that is once you add more nodes to your DataMiner system to add more resources, you can't move existing functionality. In this case, elements, you can't easily move elements to a new host. This is a problem because what typically happens is you keep on adding functionality to your cluster, it overloads, you want to add more resources, but you can't move the existing functionality, so you can't reduce the load on your existing agent or kind of load balance your functionality between agents. So what then happens typically is a bunch of people connect to the same agent because that's one URL you only need to remember, and you keep on creating elements on the same agent. After an element has been created, it can't be moved, so you keep on overloading the same system. You can see this when you try to create a new element in DataMiner Cube. Nowadays, you actually have to select actively the DMA you want to host it on, and there's a little eye icon next to it here. And if you hover over it, it says to spread the load of elements, please manually select a hosting DMA. This is because previously it's selected by default the one you were connected to, and since people often connect to the same one, everything ends up on the same agent. But this is still an active decision and an important one where people don't really realize what they are doing. So this is a problem swarming will solve. So what is swarming? Swarming is moving existing functionality from one host to a new host. So within the same DataMiner system, you move something from one host to another. Now this sounds simple, but this is technically pretty challenging. So let me illustrate this with an example. So let's say we again have a DataMiner system with 3 agents that are connected in one DataMiner system, one cluster, and they share information. If you have one element on one of the agents and you want to move it to an existing one, why is this a problem? It's because the information related to this element is stored on one machine. The other machine has no information for this element. You can see this in the diagram here. It's because the element exists of 2 important pieces of data. One is the data itself, like trending, alarms. This is the big data that's stored in tables in database. The other one is the configuration. So for example, which IP should it pull? This is stored in the element configuration, and this is typically a file on disk in the file system. And that's problematic because the other machines can't access this data. So the data is stored on one machine and the others can't access it. So how do we move the element then? Can we do something? We could transfer the data maybe. And that is, yes, we could do this, but this is dealt. This is something that already exists. This is dealt functionality. This is the export-import. And this transfers all the data. So the configuration as well as the database data. However, this is pretty slow. Anyone who has used Delt knows it goes pretty slow because you need to transfer a lot. If you include, for example, the trending or the alarms, this can be gigabytes worth of data. Having to transfer this for each element goes pretty slow. We want something much faster. So how do we do that then? Do we just optimize a bunch of code? Do we have a higher bandwidth? Do we transfer more efficiently? No, we don't transfer at all. And we can do this by leveraging one of the semi-recent features of the last years, and that is using a shared database. So for shared databases, there are currently two options. You have, of course, the storage as a service, but also the on-prem Cassandra and search cluster. This has a big benefit because these clusters consist of multiple nodes, different from the nodes that the DataMiner agents are running on. So typically these are Linux VMs in the same network. And this means that every DataMiner server, every DataMiner agent can access all data at any time because it's not stored locally anymore. It's in a database that anyone can access anyway. However, there is still a problem, and the keen eye has already spotted this. There is still these files. So the configuration of the element is still on disk. So this is typically a small file, so there are a couple of options how to deal with this. We could transfer it on request together with the element when we swarm. However, for reasons we will talk about later, this is not an option because we want this to be available all the time. We could sync it. A bunch of files are already synced between agents, for example, automation scripts or protocols, drivers, connectors. However, for configuration files, for example, for elements, this is not really a good idea because syncing is a good feature for static data. For example, an automation script doesn't really change that much. A connector is static, especially with its versioning. It's a good use case there, but for element configuration, it's not that good because it receives frequent updates. So if you mix together syncing with frequent updates, things get out of sync very quickly, and then you have some form of corruption. So we try to avoid syncing. So how do we deal with this? We simply put it in database as well. This is a small file, pretty static data, well-defined data, I mean. So we can perfectly store this in database, so we do. So this means it's always available from any agent at any time. This means the data for an element is no longer stored on the machine it was originally created on. It's no longer linked to a single DMA. Of course, at runtime, it's still running on one of the agents, but since the data is stored centrally, we can switch this runtime behavior very quickly. So how does swarming work then? Simply at startup, same as before, agents load in their elements that they are responsible for, and it's running on one of the agents. Typically, you don't really care on which agent it runs, it just has to run somewhere. So then you want to transfer it, could be for any number of reasons, but let's say you want to lessen the load on this middle agent, you want to move it to the right, you want to swarm it to the right. How does it work in practice? In practice, the moving part is only conceptually, because behind the scenes, nothing will move. What really happens is, when you want to swarm an element, the current host, the old host, unloads the elements, which means it flushes everything to database that it locally still has. It unloads it, it stops running the element. Next, it instructs the next agent to start loading it. And important to note, what you can see here, there is a temporary small window where the element is unavailable. That's because a swarm action, for elements at least, is conceptually basically a restart but on another agent. So this means you have a very small window where it's not available. And then the new agent starts loading it in, and it starts the element. So this includes still an element start. So if the element takes a bit to start up, this is also included here. And it is a swarm flow, a typical swarm flow for elements. Pretty straightforward. And the benefit is it's much faster, because it's essentially just a restart. There is no transfer of data, which means it goes much faster. So then let's swarm an element. Let's show it in practice. I have a cube session open here on a DAS cluster, actually. So a couple of agents in a cluster. Now, depending on when you watch this, DAS clustering might or might not be available yet, so they have to follow along on your own cluster with swarming. So I have here a view as well, the animals view, where I created some simple elements with an animal name, so you can easily recognize them. So the swarming takes place in the system center. You can find the system center here. Then go to agents, status. Here you can see an overview of your cluster as well. You have the 3 nodes and the number of elements per node. Here there is a swarm button, and you can swarm. Now, if you don't see the swarm button on your system, which you probably won't, that means either one of 2 things. Either there is no button, and that means you only have a single agent, so there is nothing to swarm to. Or you see the migrate button, and that means swarming is not enabled, because swarming is an opt-in feature. So you have to enable it. I will talk a bit more about that later, but let's just follow along for now. So how does it work, swarming? Here you can see the elements and on which agent they are hosted. So these are DAS nodes. So they have a similar name. Let's just focus on the last letter. So you can see, for example, the alligator is hosted on the -o at the end. Let's say I want to alleviate the -o from a bit of load, because this one has the most elements. I can choose another one and move the element to there. You just pick the element, you pick the host where you want it, and you click swarm. You can see an overview here again. Alligator goes to node F. And there you go. That's how fast it is. Blink it and you'll miss it. You will see it move fast. Let me do it again so you can see. If you're wondering what happens in the element, this is a simple element. Let me minimize this so you can see. It will just give you a small pop-up. Oh, it's swarming, hold on, and it's moving. Let's move it to the -d here. You can see, swarm it again. That's how fast it goes. Of course, this is a pretty simple element, so it starts up quickly. But that's basically it. That's how you move elements between one host and another. It seems simple, but behind the scenes, a lot is happening. One agent is unloading, syncing with the other. Hello, please load this one. And they coordinate together. Now, like I said, so here's a visual recap again. So the agent status page, and then you swarm. So like I said, what about my system? Can I do this also? Yes, but you'll have to enable it, because the migrate button is still the DELT functionality behind the scenes. It looks very similar, but behind the scenes it uses the export and import, which is much slower, because swarming is opt-in. Now, swarming also has some prerequisites. To go through the whole process of enabling it, you can go to the docs page. There's a good docs page with some explanations as well. Now, if you're more a video kind of person, there is also a Kata session where I go through the process of enabling it on a system using an interactive automation script that guides you. So then let's talk about swarming automation, because automation is the real power of swarming. This manually swarming a bit, load balancing a bit is nice, but yeah, I don't want to do this all the time. So what is swarming automation? Swarming automation is in the form of an API. Like many things in DataMiner, there is an API that you can talk to do things in DataMiner. And it looks like this. This is the whole thing. There is nothing more to it. It's pretty straightforward, so there are not really that many docs about it. So first of all, you create the helper class, and then you have to do two things. First, you select which elements you want. You can do one, you can do multiple. You select what elements you want to swarm, and then to what agent you want them. Choose the new host. Now, a bit of clarification about what these numbers mean, because there is always some confusion about this. So the first thing you need is an element, and this is defined by its element ID. It's a unique identifier. And these are two numbers you can see here, 1, 2, 3, 4, 5, 6. And that's the ID you can find in the properties. So if you, in the surveyor, let me show you. In the surveyor, if you right-click, click properties, you can see here the unique identifier. And these are two numbers divided by a slash typically. You can see this here. What these two numbers mean, there is some meaning behind this. You don't really need to know this, but I'll just add it for clarification. The first number, so in this case 1, 2, 3, is the DataMiner ID of the agent that originally created the element. And then what the second number is a unique identifier within that agent. There is always some confusion because the second number is sometimes also called element ID, but this does not uniquely identify the element within the whole cluster. So how it works is each agent has its own counter, so element 1, 2, 3, 4, 5, and by adding the DataMiner ID of the agent that created it, it becomes unique within the whole cluster. So that's why these two numbers exist. And then the number in the two agent part, the 7, 8, 9, is the DataMiner ID of the host you want to swarm to. So this is just the new host. You can also find this in DataMiner Cube. Let me show you. If you go to a view table of the elements here, for example, if you scroll to the right, so here you have the name. If you scroll to the right, there is a section called the ID. So this is the element ID, and this is the host ID. So this is where it's currently hosted, but you choose, you are supposed to choose another one. So if you go to System Center, for example, if you want to see the options, there is the agents page here, or the agents tab. These are the 3 nodes in my cluster, and you can see the ID here. This is saying like, I want my element to go to the -F here, you have to put in this number. That's what these IDs mean. There's a bit of confusion because it's 2 times the DMA ID and then the element ID is 2 numbers, but this is more or less what it means. I hope that clarifies it a bit. Okay, so what can you do with this API, with this automation? A lot of options. The first thing I did was actually recreate the Cube UI. You might say this is stupid, but this shows the power of the automation capabilities. And you might say, I don't like the UI part in Cube, I want it different. Or you might say, I'm the type of operator that does not use DataMiner Cube at all. I only work with the fancy low-code apps. You can create a low-code app that just mimics the Cube thing, so you don't have to open Cube. That's what I did. There's a picture here, but I can show this as well. I have the app open here. So I just made a simple app swarming playground where I can mimic the Cube behavior. So here on the left, you can see my list of elements on my system. So the name, the current host, the state of the element, and if it's swarmable. So if it's a check mark, you can swarm it, because not all elements are swarmable yet, but some will never be swarmable because it doesn't make sense. For example, if you have a Microsoft platform element that polls localhost, it does not make sense to swarm it, because once you swarm it, localhost has a different meaning. So if you, for example, trend your CPU, you will suddenly have a different CPU load. It does not make sense. So these are not swarmable. It will be blocked by the system. On the right, you can see a DMS overview. You can see how many elements you have. So I have 94 here, the nodes in the system, and how many elements they have, 31, 29, 34. It will also show the non-swarmable elements. Currently, I don't have any, and this will be a different color because these you can't move. So then simply the same thing as in Cube, you select some elements you want. For example, let's say I want these first ones to be on agent, let's say -d here, the first one, and I just click swarming and it will start and it will move, and you can see it happens very fast. Goes from active to swarming to active again. And you can see how fast it really is. It's much faster than DALT because no data is being transferred. That's just one thing. You can see here again. But let's talk about some real use cases, some things you couldn't do before with DataMiner system. So the first one is load balancing. So something common we hear about people using a DataMiner system is what I talked about in the beginning. You want to kind of balance your cluster after, for example, adding extra nodes for resources. So in this simple example, let's say you have one agent, you put a bunch of elements on there, let's say 5, and this is too heavy, the system is getting overloaded. Let's say these are 500 elements, for example. You want to add more resources. You can add more nodes. You form a cluster, in this case of 3 agents, and now you want to balance it because the high load is too much for one agent. What you can do with swarming is just pick some of these elements, click on one of the empty agents, and you click swarm, and it moves over and it load balances your cluster. So in this case, you could, for example, say, put 2 on the left one and 1 on the right. But you can do this manually. But this is a bit tiresome if you have to do this all the time. So you could automate this. You can write an automation script using the swarming API that calculates all the elements in the system, calculates how many should be on what agent, and then swarm them. And that's exactly what I did. And I have an example here in the app. Let me show it live. So in this last page, I have some automation capabilities. So let's say I want to load balance. So I have here a button, load balance, that triggers an automation script in the back that just takes in all the elements of the system, takes in all the agents, it calculates, let me put the same number of elements on each agent. So this is pretty naive, simple implementation. You just balance by the element count. They treat all elements equally. This is not always a good idea, but for this demo, we will do it like that. And then make sure each agent has the same number of elements. So when I click this, a script triggers, it swarms it, and it goes balanced. Not much happened because they were already pretty balanced. Let me do it in the app. Let me swarm a bit more. Let me just take a bunch and put it on the middle one. You can see it here. Goes pretty fast. So let's load balance this again, see what happens, and it will balance it again. So it's important to be aware of what's happening. You just see the bars moving a bit, but behind the scenes, of course, what happens is all these elements in your system, they start moving, they will temporarily become available, and they will restart. So let me show this again. When you do a big number of swarms, you can see this in the app. So let me put them all on the left one. You can see this, these elements are all moving pretty quickly because swarming is of course very fast. And all these are in the new agent. So yeah, this is just pressing one button and some bars move, but behind the scenes a lot of stuff is happening. Then there is a second important use case, and that's swarming away from an agent. So let's say you have a balanced setup and you actually want to empty out one agent. Let's say the middle one, you move everything away. Now, why would you do this? There is an important use case, and that is you want to bring one of the agents down without impacting operations. So in this case, you could bring the middle DataMiner offline without impacting any existing functionality. One use case is, for example, when you want to do OS level updates. So for example, Windows updates, or you want to do some other maintenance on the system. This way, you can do it in your whole cluster one by one, and you have fully 100% uptime on the remaining part of your cluster, so all functionality is still working as intended. Now, an important note here is a question we get a lot. Can we do DataMiner upgrade as well, DataMiner updates? And the answer is no, we can't do that because the whole cluster needs to be running the same version. That's a hard requirement within DataMiner, so swarming cannot be used for that. But perhaps in the future this will come as well. So this is also something in the app. I made a script for that. So what the script does is you select one or multiple agents here. For example, let's do the last one, the -o at the end. And if I click this, all elements from this agent will swarm to other ones in the cluster. And this means I can bring this agent down, do maintenance on it, without losing the functionality of the other elements. So let's see this in Cube. Did all the elements move over? Because the app says 1. Yeah, so all of them passed that. Yeah, here it updated as well. All elements moved over. You can bring it down, and then after you are done with your maintenance, you either pick another one or you load balance at the final one. So let's say I did this maintenance on the -o, I can do it again on the -d, swarm away this one. It will just, my script balances between the other agents, so in this case it will just move it to the other agents. I can do maintenance on this one, and so on, so on. And at the end, you just balance again. So pretty useful case, doing maintenance on your whole cluster without losing your element functionality is very good. And then the third use case, arguably the most important one, is the high availability. Like I said in the beginning, there were some requirements where we didn't want to ask for the element configuration. That's because there is an important feature that this allows. If we put the element configuration in database, there is an important feature that we can make, and that is the high availability of elements. So let's say you have your typical cluster again with 3 agents, with some database, and there is some elements on each system. Let's say you have a critical failure. So these DataMiner agents are just virtual machines running somewhere. The power is lost to the building, the server blade is corrupt, malfunctioning, whatever. You can lose your agent. This can happen at any time, always. However, previously this meant you would lose the functionality of your element. The agent goes down, the element is gone. You can't bring it back, really. However, with swarming, you can. So let's say you lose your element during a critical failure. Could be for a number of reasons. You want to bring it back. With swarming, this means all the data is stored in the database, as well as the configuration. This means that all the other agents in the cluster have everything they need to just simply start the element. So in this case, the swarming, you have to do this via swarming, but in this case, the swarming is just starting on a new agent without the unloading part. So you can just swarm to another agent and you have your element back. Then you have time to investigate, okay, what went wrong with the server. You don't have to do the other way around where you first check, okay, what is wrong with this agent? Can we bring it back? Yada, yada, yada. No, you just bring back functionality first, get everything working, and then post-mortem you can do analysis of what went wrong. So some people might be worried, yeah, what happens now if the server comes back? Just like normal. It starts up, it asks the database, can I get all my elements, all the information I need? And it will say, you're not hosting any elements because it has swarmed to another agent. Just like normal, nothing wrong. This might sound like something familiar because we have a feature in DataMiner that's also high availability related, and that's failover. So let's do a small comparison to swarming versus failover because these are not compatible. You will see when you go to the swarming documentation, there is a hard requirement, a prerequisite that if you want to enable swarming, you can't have any failover agents in the cluster. So let's look at the typical failover setup. You can, of course, have a bigger cluster, but let's just look at one pair, so 1 + 1, and you connect with Cube to the system. Now let's say one agent has a critical failure, the second one will take over, you fail over from one to the next, and that's okay, this will do it. This will have the same functionality like swarming. However, there is a big disadvantage. If you do this while connected with Cube, you're staring at this window. The agent is switching. And if you have a big system, this can take a bit. So then you don't know what's happening. Is your element okay? Is your data okay? Is your whole operation okay? Yeah, you're just waiting. Okay, going online. Of course, if you have a bigger cluster, you can connect to another agent and you will see part of your system. So you won't see what's happening on the failover pair, but on the other agents, you will still have visibility. And with swarming, you can do the same. So let's say you have again two agents, this time no failover, so just two regular agents working together in a cluster, and you have some elements on one agent. And let's say you have critical failure on the left one here, you can just move everything to the right. You just go one by one. All right, let's do a failover-like setup, and now everything is moved to the other agent. It's basically the same in this case as failover. However, there's one advantage. If you have a pair like this, your cube stays connected the whole time. Everything happens live. Your cube's not disconnected. You can see the elements move in real time, just like you saw me do in Cube before. You could see the elements move. However, the real power or the real advantage of swarming compared to failover is what happens if you have more agents in the cluster. So let's say instead we have 5 agents in the cluster. And in this case, we only have one agent with some elements. This agent, the bottom one, has a critical failure. We can swarm to the other agents in the cluster. However, important here is we can swarm to multiple agents at the same time. So what happens in practice is these elements all move at the same time to different agents, because the swarming is dominated by the loading part, the starting part. So it scales linearly almost with how many agents you have. So in this case, swarming 4 elements, doing a failover between 4 agents is the same time as swarming 1 element to 1 agent. So it is much, much faster than failover, because you're using your whole resources, all capabilities of your whole cluster to work at once, to get stuff working back as quickly as possible. That's one big advantage. It's much, much faster, and it scales very well with bigger clusters. This is also something you can show in the app. There is no automation for it yet. But you can do it manually. I won't do it live now because it takes a bit to make the server disappear. But I have here a small recording where I do it. So you can see here the same 3 nodes. On the right, you can see the agent went down. I have the little red circle. The agent is down. It's not reachable. And then what happens if you're unfamiliar, for example, in DataMiner Cube, you will see the element says host unreachable. And it says here in the app as unavailable. So these elements are unavailable. If you would want to do a parameter set, for example, it won't work because it can't reach the agent that's currently hosting this element. Now what you can do with swarming is just select it, because there's one thing you can do now. If your element is unavailable, you can still swarm it. So here I select some of the unavailable elements, I select a live host, and I just swarm it to that host. And you can see here the elements update in real time, starting, active, and just like that, we have them back. They are started, they are working again. So if they are, for example, talking to something, device, monitoring something, whatever, you get it back as quickly as that. That's an amazing feature, and that's also why in the beginning we talked about the possibilities for element configurations. You can't ask a remote agent because that would mean the high availability functionality would not work. You want to be able to swarm from an agent that's no longer there, because this makes it so you can easily recover from critical failures like this. All right, that's some of the common use cases. Let's wrap up with a look ahead at what's to come for swarming, because there's some exciting things coming hopefully soon. So the 3 common requests you get for swarming, 3 common features, are about getting swarming to more functionality and also to do some automatic high availability. Like I showed before, the high availability is still manually. You have to select your elements you want to swarm and you swarm them manually. You could script your way around it, but yeah, that's not really convenient. So the first thing is failure detection. We want agents in the cluster to kind of monitor each other and say, oh, this one is gone. Let's steal his elements, let's swarm them to the remainder of the healthy cluster. And then we get the functionality automatically back. So basically, if your server, the power is dropped, like within a few seconds, everything is back to business. Very nice feature. Then the other two is, like I said, getting functionality to more, getting swarming to more functionality. The two most requested ones are virtual elements. So virtual elements are currently not swarmable yet. This is one of the limitations. And this includes things like dynamic virtual elements, so like a DVE. Currently not possible, but we anticipate this soon. And then, of course, services. So a lot of systems have services. This is a highly used feature. And currently, you can't swarm these yet. So these are still linked to a single DMA. And the plan for this is to just do the same thing as we did with elements, make them independent of the host DMA and just swarm them to only one. Thank you for watching this and hopefully playing a bit with swarming. We'd love to hear your feedback and we'll catch you on the next one.